All right. So, like Diana said, my name is Bartek Słota. Bartłomiej Słota is my full name, but I think that calling me Bartek or Bart, if you like, it's way simpler. I'm a software developer. I'm a consultant, a mentor, and a trainer as well. What I'm doing every day, apart from writing code, obviously, is helping companies to increase their delivery and operational performance. I design systems, I design applications, I mentor people to become better professionals. I also conduct trainings about system design, domain-driven design, refactoring, quality assurance, everything that a professional developer and architect should know. And starting my presentation, let me start it with some numbers. 417. According to State of DevOps report from 2022, 417 times more deployments every year are being made by so-called high-performing teams compared to low-performing teams. And what does that really mean? It means that these teams are able to respond to changing business requirements much faster than the others. And it also means that the feedback loop between deployment and customer feedback is much shorter. And until recently, in order to objectively compare teams in terms of delivery performance, we use so-called 4 key metrics. And these 4 key metrics consist of, like the name implies, 4 things. The first one is lead time for changes, which is the time that the time between merging your changes into the trunk branch and actually deploying it on production. The second metric is mean time to recovery, which means the time it takes to restore a system from a failure to its usual functionality. The third one is deployment frequency, which is the frequency at which the code is successfully deployed to production environment. And finally, change failure rate, which is the percentage of deployments causing some failure in production. And it turned out, which you can read in the State of DevOps report, it is not enough. Meaning, for these measures to be meaningful, they need to be placed in some broader context, which is called operational performance. And operational performance consists of a set of measures cataloged under the name that you can see on the slide, reliability. And it is a set of measures that tell whether and to what extent, of course, the team meets expectations. And these expectations are connected with scalability, with performance, with availability, with latency. And the research confirms also that teams that are characterized with the greatest maturity, which is the best values of mentioned metrics, they use certain practices, patterns, they use certain tools. And if you and your team, of course, want to be in this group, you most likely need to use these practices, patterns, and tools too. What are those? This is version control. This is continuous integration. This is continuous delivery. This is providing flexibility, meaning the flexibility of the company in the organization, in the area of organization of work for employees. And finally, loosely coupled architectures, meaning the extent to which teams can make major changes to their systems without being dependent on other teams and changes of the other teams. And this means that it is not only continuous integration, continuous delivery, or automation around that, what creates delivery and operational performance. And the architecture must be there as well. So according to the State of DevOps, it is the loosely coupled architecture that allows teams to achieve high delivery and operational performance. And maybe you already have microservices or any kind of distributed architecture, and maybe you face some problems, like maybe you have to go to synchronization meetings with other teams every week. Maybe your team don't have clearly defined responsibilities, and you write code where it is actually needed in whatever application is needed. Maybe the same features are developed by different teams in different places at the same time, so you have lots of duplications around. Maybe you have an event-driven architecture, and everyone promised you that teams will be decoupled, like software will be decoupled, but you have more coupling than you ever imagined. And maybe your team is a bottleneck in delivery process of other teams. Or maybe you just work with a monolithic application and you're wondering how to plan your migration into distributed or modular architecture in general. Or maybe you're in the process of this transformation already and you just want to make sure the direction you're heading to is right. If any of these statements resonate somehow in your head, it's good that you're here because the presentation is for you. If not, don't worry. It is like a screwdriver. You can have it in your garage and don't need it, but it's still better to have it in case you have something to do at your home. So in this presentation, I will try to share with you. I will share with you my experience, the experience I gained working with tens of companies, conducting trainings to companies, and I want to share with you the most dangerous threats in our software architecture, and I will tell you how I solve them working with my clients. So we will be working with a simple example of a company, a system that is responsible for, that actually makes money for from publishing and publishing videos and buying these videos by others. Here you can see some effect result of the process level event storming. Maybe it is not readable now, but we will zoom in and take a look at each and every part of this processes. So in order to make money, we need to have some price lists, and we have two types of price lists. First one is related to publishing. We have publishing price list. So each time someone wants to publish a video, he or she needs to pay us money so that we earn. So this is the first thing. And the second thing, when you publish the video and you want others to download it, you need to assign a price list to your particular video. So there's also a download price list that can be defined, and at any time you can withdraw particular download price list, but only if there are no movies connected to the prices. This is a business rule that we need to follow. Second business process, let's say, is related to user registrations. So you need to register to use the system, and only the registration, if you are only registered, you can only search the catalog of videos. You cannot publish them, you cannot download them. In order to do so, you need to verify your identity. So we are sending the email notification with some verification link or something, and if you verify your identity, then you can publish or download some videos. And there's also a business rule that tells if there has been already an registration attempt within 1 hour, we are just not sending the notification again. Let's go further. Video publishing. This is actually the core of our system, the core of our business. And what steps do we have here in this process? Well, first of all, a customer that wants to publish a video, he or she first needs to create a catalog, to catalog it, to create some metadata, enter some metadata about the video, like title, like type, or whatever it is. So we are creating a catalog, then we are uploading the file, and we are assigning the download price list to a particular video. And the moment we upload the video, the access is granted to this video to an auditor. Auditor is our employee that checks the quality of the video, it checks the content, if it doesn't contain any inappropriate stuff. So the next step is authorization. Video is authorized, and as soon as the video is authorized, we can publish it. And the moment the customer publishes it, the fee is charged. So we are taking money from the customer. We are enabling access granting, because when you publish the video, no one has access yet, and no one can download it until you click the publish button, let's say. So then we are enabling granting the access. Video is published, and the notification is sent to the customer. Of course, after publishing, it's not the end of the world. We can withdraw the video. After withdrawing, we can delete the video. We can publish it again, and etc. So let's move on into the purchasing access. If you want to see the video, you see the catalog. You just choose your video you would like to see. You are and you want to purchase the access. The fee is charged. The access is granted to you, and then you can move on to downloading the video. And as a result of video downloads, we are calculating the popularity. And the vital thing is that the purchasing access is a very important part of the business, and there are going to be subscriptions or patron plans in the future. So there are going to be a lot of changes, because right now you see that it's a very simple process, but there are going to be more. There are going to be more use cases there. So this talk is not about heuristics of how to design or how to distill subdomains, how to design bound context. We have too little time to walk through all these heuristics. So let's assume that the modules that you can see here are right, okay? So what do we have here? What subdomains can we identify here in our business? So we have a couple of generic ones. Generic subdomains are those that are not specific to our business, that are not defining that don't make us competitive on the market. So this is something that everyone can have in every system. So first of all, we have user management, which is responsible for user registrations or user verifications. We also have price list management, which is also very generic. We just create price lists. We are withdrawing price lists, etc. There's also a payment service subdomain that's responsible for charging our customers. And we also have two more generic subdomains. First is file storage, and the second one is notification sending. These 5 generic subdomains you can find in almost every system that makes money, in every company that has its own software. There are notifications, there are payments, there are price lists, there are users, there are files stored somewhere else. So these are generic problems that you can find almost everywhere. And we also have 2 core subdomains that make us competitive in the market, which is video publishing and access selling. And we also have 2 supporting subdomains like popularity calculation and access management. And what can we do with such knowledge? Because subdomains are located in the problem space. So if we are going to make a design of our system, we need to walk from the problem space into the solution space. And in the solution space, we have in domain-driven design, we have a pattern called bounded context. And let's assume that we design bounded context in a very nice way like this. In each and every domain, we do have a context assigned to this. And we also have some curves that represent the relations between particular contexts. And we will walk through these relations in details very soon. So let's assume that this is a good design of our bounded context and their relations. Of course, if we want to make our architecture and our system elastic, and we want to make it robust, we cannot forget about our organization. We need to assign teams to particular parts of the system. Each team should have a very well-defined set of responsibilities. specifically, particularly every team, every service, every bounded context should be assigned to at most or exactly one team. There shouldn't be a situation where two teams are implementing stuff in one bounded context. That's unacceptable. So let's assume that we also have a reasonable division of responsibilities. We have 7 teams, and there are a couple of contexts that are assigned to a single team. For example, we have price list management and payments. They're pretty much connected in this in the business sense, though, so they are handled by team number 2. And similarly, access management and access selling, they're also very much connected, so they are handled by team number 7. So let's have a look at how it could be implemented. And what I'm going to show you now is the thing that I'm seeing almost every architecture that I'm reviewing, that I'm working with. Right? So let's assume that we have this relation. We have video publishing, which of course needs to have some information about users. So it is listening to events like user registered or user verified. It listens to events using the Kafka. And similarly, we have access selling bound context that listens to events user registered and user verified. That's fine. Let's move on. We also do have notifications, and we have, because we, as you have already spotted, that we have an kind of a event-driven architecture. So every context, every application that is implementing a particular context is emitting events, and if somebody or some system wants to react to those events, it just listens to the stream of events and does its own job. So the example of that we have in notification sending bound context, and it listens to events like user registered, like video published, video withdrawn, popularity calculated, access granted, access revoked. Every event that should trigger notification send out is emitted, and notification sending is listening, is subscribing to those streams of events. And similar situation we have in terms of payment handling. Here we also have some HTTP connections. We walk through that. So in order to publish the video, we need to know that there's a price list somewhere in the system. So we are reading the current price list. We are emitting the video published event, and publishing payment service is consuming that event. And based on the price list, it charges the customer. And when the access is purchased, also the access purchase event is emitted by the access selling component. Payment service also charges the customer. Regarding the connection between video publishing and access management, each time the video is published, added to catalog, withdrawn, or whatever, the access management need to enable the access, right? You remember we were saying that if you publish the video, if you create an entry in the catalog, we should enable access granting. So that's why the access management is listening to those events. And at the same time, when we are publishing the video, there's a rule that says that you cannot withdraw the video. You cannot delete the video that someone has access to or bought the access to in last month or two. So we need to read the current access grants from the access management. And what we have looked at were particular connections, but we're not looking at the business process end to end. I'm seeing that you have a couple of questions, like Diana mentioned. I will try to answer them at the very end. All right. If we look at the business process, it can work like this. Whenever you want to publish the video publishing system takes care of the first command. The blue card is blue sticky note is stands for command. So it starts processing the process, and first event that is emitted is that video publication request was received. And based on that event, you can see that the payment service is consuming that information and charging the customer. And the same happens for the access management. Access management listens to this event and emits access granting enabled event. And based on that events, with number 3, we publish an event video published. So if we process the payment, if the access granting is enabled, we can claim that the video is published. And based on that, the notification is being sent out from the notification sending context. So if we add one more thing to our business process, I hope you are following. I know it is always difficult to know the new thing, the new process on the presentation, but I hope you will soon get the essence of it. Imagine we have a new requirement that says that the access granting should be enabled only after the payment is successfully processed. So in general, we can think of this as a situation where we try to care about the order of event consumption, because in the previous case, it didn't matter when we consume the video publication request. This video publication request received in the access management. We didn't care if it's before payment, after payment, in the same time. We didn't care about that. Now we do care, because we now want to have the payment processed before. So what we can do in an event-driven system, we can listen to this stream of events from the payment service in the access management. We can consume the event, and then based on event number 3 and event number 2, emit the access granting enabled. And the rest of the process is the same. And if you're Polish, I don't know if there are any Polish people, they should recognize the image from one of our funny cartoons. It means that there's something wrong there. Event-driven architecture, everything should work fine, right? But there might be some problems that organization can face, and that can be very, very harmful. What are those? Let's walk through each and every of them. So let's have a look at the problem of notification sending. What you could already see is that notification sending service, let's say that every context is implemented by service. This notification service is listening to 4 streams of events: users, video publications, popularity calculations, and access granting. And it turns out that there are some rules that tells whether we should send notification or not. For example, we should send notification when user is registered if there has been already a registration, only if there has not been a registration attempt within an hour. So if you are trying to register a couple of times during the hour, we are just sending you just one verification link. So this is a business rule that we need to implement somewhere. There's also a rule related to popularity calculation. We are sending the notification about the popularity to a customer that published the video once a week, or when there's an increase of popularity of at least 30%. There's another business rule that drives whether we should send a notification or not. And finally, we should send notification about the access granting, access revoking, unless it's been more than 3 months since last download. So if you haven't, for example, if the access to the video that you purchased was revoked, but you haven't downloaded the video for longer than 3 months, we won't be bothering you. We won't be sending the notification to you, right? So you can see that we have just a couple of exemplary business rules, and where usually in this architecture, these rules are implemented. In the notification service, of course, right? Because this is event-driven architecture. How could I do that differently? So the problems, there are many of those here, are following. First of all, the notification sending becomes a delivery bottleneck, because now I'm not only listening to a lot of events from a lot of streams, but I also need to know the business processes that stand behind those events, because I need to understand when should I send the notification and under which conditions. And maybe in order to calculate these conditions, I need to listen to a couple of other streams of events. So I might become a delivery bottleneck. Next thing, the notification team, because there's a team behind the service, depends on many other teams. It is not only the case where if these people from user management, video publishing, popularity calculation, they want to send notification, they come to us, to the notification team, and tell, hey, we need to send a notification like this and like that. It's not enough, because the notification team needs to have a communication backwards, because they have certain requirements regarding the data. They need to know to whom send the notification, which template should be chosen, etc. So the communication is required, and the communication is de facto two-way, because the requirements come from business contexts. And there are even more problems. The cognitive load of the team members increases, because they need to know all the business processes. They're not only the specialists of how to send notifications through different streams, how to integrate with, SMS gates or mailing gateways or whatever. They also need to know the business processes behind that. And the context implementing the sending notification is no longer generic, because it has the knowledge about all business processes. So we lose the genericity of the context. So we made the distillation of subdomains, we assigned the bound context, everything was fine. But the boundaries are very blurred, and it turns out that we are no longer generic here. Someone is also limiting our core subdomain, because there's a prioritization required. You see, if there are numerous actors that want to have something in the notification service being made, I need to prioritize whose job is more important. And in these clients, there's a core subdomain, so it always be problematic to deliver functionalities when there are a lot of stakeholders. Let's have a look at another example. In payment service, we have a very similar situation. This is a generic service, but now it needs to know when should we charge the customer. It knows that we should charge customer when the video is published, when access is purchased, and there might be a lot of different business rules behind that. So they can quickly share the fate of notifications, and the payment service again affects major subdomains, the core subdomains, video publishing and access sending, because they also can have their own requirements regarding the structure of events. There must be maybe information about the account, or the currency or whatever. If we have a look at the connection between video publishing and access management, you see that access management is consuming the events from video publishing, like video added to catalog, video withdrawn, etc. And the other way around, the video publishing reads current access grants using REST API. Here we have lack of the clear communication structure, because we have a cycle. Everyone depends on everyone, right? So every cycle in software development, in software architecture, is very dangerous, because it couples not only modules, not only systems, but also teams. They need to maintain the two-way communication, and the communication is usually the most expensive thing in software delivery, and we don't like this. This is the reason, because this is the reason for avoiding this kind of connections between systems. And again, the generic context forces the core context to change here. And finally, let's have a look at the business process. Here is the simple version. We'll have a look at a bit more complicated version where access management can enable access granting only when the payment is processed. What do we have here? The general question when you see the business process or when you need to identify the responsibilities for particular parts of the business process in event-driven architecture, is that the business process knowledge is increasingly dispersed. So if I ask you, where is the information about how the business process looks like? The answer is, there is no such place. So, and this is very problematic in terms of readability of the system, maintainability of the system, etc. So another question, how to test the business process? Usually what happens in this case, what I observe working with companies, is that when you have that kind of complex business process, you are doing end-to-end testing. And how to do end-to-end testing? You, of course, need to have a testing team. And the testing team will also be cognitively overloaded. They will need to know all the business processes for all the teams. There will be delivery bottleneck because they need to test everything. If they need to test everything, you can forget about continuous delivery because they need to test that. So that's very problematic in terms of software delivery performance. And finally, how to monitor business process. How to answer the question, where am I currently in the processing of my particular instance of a business process? It is also barely nearly impossible to answer that question in this kind of solution. So, and finally, why does the generic or supporting context like access management need to know that there are some payments? They shouldn't care about any payments. They're responsible for accessing, for giving the access to particular assets. They shouldn't be aware of any payments going anywhere in our system. So what did we do wrong in this design? Let's walk through. The big problem here is in terms of designing systems that I identified, not only myself, but also there are many other people, many articles, many books about that. For example, if you want to look for some sources about how should we approach the problem of handling software architecture as the architecture of not only the software, but the whole organization, there are names like Eduardo da Silva, there are names like Nick Tune. There is a fantastic book that I will refer to later, which is called Team Topologies. But there's also a thing that has been written down and described by Eric Evans in his book about domain-driven design in 2003. And Eric Evans described the types of dependencies between teams. Because why are we talking about dependencies between teams? Because it turns out that, as the research confirms that, it turns out that there's a strong relationship between how the architecture in terms of software is structured and how the organization is structured. And there are certain patterns that have certain, I forgot the English word, so I need to work this out. So the more friction you have between teams and your architecture, the worse is your operational and delivery performance. So we need to find to choose the best dependency types between your teams to optimize your delivery and operational performance. This is what we are going to work on now. So there are basically three types of dependencies between teams. The first one is mutualism. If teams are mutually dependent, two teams must coordinate their efforts to deliver valuable functionality. Two artifacts or systems from separate bounded contexts, they need to be delivered together. And when I come to a company talking about that, everyone is nodding. Yeah, that's in our case. Two teams need to deliver two systems at the same time in order to have a working system. So this is where you have a mutualism effectively. In mutualism, there's usually a feedback relationship between data and the functionalities managed by these teams. And the most problematic thing, and the thing that we don't like, is that both teams either achieve success or face failure. And I don't like that situation. I don't know how about you, but I don't like that situation when I fail because some other failed. I did everything right, they failed, and we all face the same fate, share the same fate. So we don't like that situation. We don't like being that dependent. So we need to avoid being mutually dependent. The second type of relation is freedom. We all like to be free, not to talk to any teams, of course, apart from social, let's say, part of our lives. But we don't want to talk too much to communicate with other teams. This is the best possible way from the perspective of a software developer, not to talk to any other team, to do whatever you like, however you like. So this is a dependency between teams where you actually don't have any dependency. You don't have relation between teams. There's no need for cooperation between two teams. There's no connection between the success of one team and the failure of another. That's perfect situation. And changes in one context does not affect changes in the other. And so it might look fine from the perspective of single team, but it's very dangerous and very costly from the strategic perspective, from the strategical perspective of the company. Because if you, for example, have to integrate with some payment gateway, right? And if teams are not talking to each other, and imagine we have 5 teams, we will have 5 integrations with the payment gateway. This is too expensive to maintain and develop the same thing 5 times, not talking to each other, right? And when some regulatory requirements comes in, you will need to have changes in 5 systems, and you might even not know that some other team is doing the same thing that you did. So from strategic perspective, you neither want mutually dependent teams nor free teams. What you want to have instead is the upstream downstream relation. And the upstream downstream relation is when the actions of one team can directly impact the actions of the other team. And upstream is always the leader. Whatever they do, the downstream team will be might be affected. And I will give you some examples very soon what this really means. But if we optimize for having upstream and downstream teams, we should make a decision which team depends on which. All right. So, for example, this is an exemplary map where each relation between bounded context is assigned with the upstream, downstream, the U letter and the D letter. For example, if we have a user management service, or maybe video publishing is a better example, we have video publishing that is dependent upon the upstream notification sending. And that's fine, because we want to be dependent on them, because we want to use their API, because we want to send the notification. So if they do not deliver the functionality, we are affected. If they deliver the functionality and it works great, we are affected as well, positively, but still affected, right? So this is the relation between teams that we want to have. And what other implications the upstream downstream relation will have or should have on our tactical decisions, or let's say integration patterns? Because whenever you are on the upstream side, you're the owner of the API. So if you're the owner of the API, if we are talking about commands, the command is yours, right? You are the owner of the API that lets others send the command. So if you ever want to send a command, the command is an imperative request for executing some action, for example, send notification, charge the customer, whatever it is, or make a reservation, or whatever, place the order. You are not the owner. You're the downstream. You're using some API. So if you're upstream in terms of commands, the upstream team owns the API. The same goes about querying data. If you want to query data, you're dependent upon the API. You're dependent on the other upstream team. And if you are emitting events, you're the owner of the event, because event is the part of your API that you're publishing to the outer world. So whenever you have command, query, event, whoever owns that is the upstream. And that should be the rule. Of course, there might be, and there are some exceptions, but we are not going to dig into that. We would need to spend 3 days on my workshop, work through all these cases. But 99% of situations, this is the way that should that you should follow. This integration pattern should align to upstream downstream relation like this. And what implication will that have? You'll see very soon. And if we identify the relation types between particular teams implementing particular bounded context, it is not enough, because okay, we know who is upstream, who is downstream, we know who can send a command, who can send an event, who can query some data, etc. But are there any other patterns that can help us out in choosing the best tactical integration patterns? And it turns out that in 2003, and the Tackling Complexity in the Heart of Software, Domain-Driven Design by Eric Evans, the Blue Book, we have the answer there, and the answer is called context mapping. And the context mapping is a set of patterns that are connected to very broad, very broad set of relations between not only bounded context, as the name implies, but also teams that are responsible for those bounded contexts. And I always have a problem with the naming in the software world, because context mapping suggests that there is some mapping between contexts. And by mapping, we developers tend to think about mapping data from one context into data in other contexts. We are thinking of data structures, I know, maybe names, maybe some behavior, something like that. That is 30% of what context mapping is all about. 70% is about teams, dependencies between teams, communication, and other implications. And I will walk you through that in this talk. So let's walk through each and every pattern, and I hope it will be a bit clearer after that. So let's start with the first pattern, which is open host service. Open host service can be identified as, can be understood as the public API for numerous consumers, numerous clients. A good example is Google API, Facebook API, but of course we are not in Google, we are not in Facebook. You're doing your job in your companies. So you may ask yourself a question: where should I use open host service? And the answer is very simple. You should use open host service in every generic context. So whenever you have a generic thing that is multi-purpose, for example, payments, you shouldn't care about who wants to charge the customer. It should work pretty much the same. Similarly, in terms of user handling, in terms of notification sending, etc. These are the candidates for using the open host service. And the open host service offers offers the common model, common set of functionalities for many different purposes. And what you need to remember is that the owner of the open host service is always the upstream team. And if we have a look at the top right corner, you have the three things written down. These are the perspectives from which we are analyzing the context maps. And you can see that this particular pattern doesn't tell us a thing about model propagation. It doesn't tell us about any mapping anywhere. It tells us about the API. It is the API, it is the interface. So it is kind of a technical pattern. And also it tells us a lot about inter-team dependency. Why inter-team dependency? Because you may be wondering how this API is created. It is created by consortium. You need to gather all those clients, then to tell them what are their needs, and you need to distill the generic version of that can handle most of their cases. Nothing specific for video publishing, nothing specific for access setting, for anything. There must be a generic multi-purpose service. So it tells us a lot in terms of, for example, product management, because if you're the product owner of a video publishing team, you know that you cannot just go to the payment service team and tell them change this and that. No, you cannot do that, because there are plenty of customers. You need to find the consortium. You need to check if all other teams are fine with that change. So it's not that simple when you have a generic service. It tells a lot in terms of organization of your work. Next thing, published language. It is a pattern that is very often connected with the open host, and I will tell you, and I'll explain it to you by example, because the definition that you will read in the book is like, it is a very well documented language shared by different contexts, and it doesn't tell you a thing about what it really is. So imagine a situation, for example, where we have a payment service that contains a model like business object, like money transfer, and the money transfer contains accounts from account to account. I don't know, the amount, the currency, the exchange rate, and plenty other stuff that you don't want to know. You just want to make payment, right? So it might be a situation where you don't want to talk with that payment service using its very complex and specific model. You want to have something simpler. So we might all agree to have a model that is not specific to video publishing, to access selling. It might be not specific to payment service, but it's only used for the purpose of communication. And that is a published language. It is just another language. So if we connect these two patterns, join these two patterns together, published language and open host service, we have an open host, which is an interface. And when you have a method of this interface, you won't have that, I don't know, post method slash money transfer. No, you will have post slash payments. You will have the language and all these fields in the communication. This will be they will be aligned with the common model called published language. And you see that this time we are not telling about any technicalities here. So it is not a technical pattern, but it tells us about model propagation, because we know that this model is used for communication. It's not specific to any service. And finally, it also tells us about inter-team dependencies, because it's also something common, something shared. So we cannot just change this like that. You need to have, again, a consortium. You need to have an agreement of all interested parties. And now let's talk about how to integrate with APIs. You can even you can either be lazy or not. And if you're lazy, you're a conformist. And if you're a conformist, you are utilizing someone's functionality, data, etc., and you just accept the model as it is. So if payment service tells speaks the language of money transfer, you take the money transfer. You bring the complexity to you. If they change, you change. If they fail, you fail as well. So this is a situation where you just are using the model of external service. It, of course, it creates the coupling between our model and the external model, but there are certain situations when this is fine. And this situation is, for example, when there are regulatory requirements. You're obliged to follow certain rules. You need to, when you want to store or use or process, for example, some financial data anywhere, you can do that, but they need to be structured like this, like that. There are many regulated environments. There's telecommunications, finance. There are many places where even e-mobility is regulated a bit. So you can face that in different places. So this pattern, as you see, it is the first pattern that is strictly connected with model propagation. It doesn't tell us anything about inter-team dependency because it's your local decision, and it doesn't tell us about any technical things. So this is the first truly model propagation related pattern. Next one, if you're not that lazy, you can use the anti-corruption layer pattern, which is just about translating one model to another model, it enables us transforming the external model to ours and ours to the external model, and it reduces the coupling between models, between services, between teams to one layer, because there will be a coupling. And technically, it is usually an adapter pattern. You have some interface, and you have an implementation that this interface abstracts you away from the complexity of the service of the external model. And here you have that the complexity is placed in the adapter, in the class that actually implements that interface. And the very vital thing is that the ACL is implemented by the downstream team. What I've observed a couple of times is that the ACL is delivered by the upstream team. And the problem here is that if someone delivers the ACL for you, you're actually the conformist. And in terms of software, the same, I mean, the communication will be pretty much the same. The same streams of bytes will travel throughout the network, and you'll get the data you need. But organization-wise, you will be a conformist towards someone else's model. So if you want to have a change to adjust this model, this ACL for your needs, you cannot do that on your own. The other team, the upstream team, needs to do that for you. And are they generic then? No, they are not. Maybe the context, the implementation is being held somewhere in a separate service and is generic, but in terms of the overall communication, they're not generic. They're rather customer supply, which we'll talk soon. So here we are talking about modular propagation. It doesn't tell us about the technical solution, doesn't tell us about inter-team dependency. We are just looking at the model propagation. Yet another pattern or anti-pattern is shared kernel. Why I'm talking about that kind of anti-patterns, because context maps has not been implemented only for creating the 2B architectures, for designing architectures. They're also useful for identifying the current state of your system. So whenever you identify that anti-pattern, you know what to do with that and what problems you're facing. So if you see something that you think is an anti-pattern, you would never use that. All right, you might never use that in the future, but you might already have that in your company. So it's good to know what patterns are there. So shared kernel is a subset of domain model that is shared between teams, and it usually has the form of library or a shared database. And as you may notice, it causes a lot of coupling between teams, between software. And one of the biggest problems here is the responsibility problem. If something fails, who's responsible? Usually no one is responsible then. So if something is shared, no one is responsible. And that's the most problematic thing in operating with shared databases and shared libraries. And whenever you use shared kernel, your teams are mutually dependent. We already know what mutualism means, so we don't want to have that. And just one caveat here. Please remember that when we are talking about shared library, I don't mean that you shouldn't be sharing libraries like library for encrypting or decrypting, or library for, I don't know, JSON deserialization. It's not about that. It's about domain model. So if you have a library that is handling, I don't know, customer related processes, activating customer or whatever, if you have that kind of library, you have a big problem. So we are talking about domain model here. So and what it tells us, the usage of that pattern, what does it tell us in terms of these three perspectives? API technical, it is a technical pattern because there is a physical artifact that is shared. It is a model propagation. There is one model to rule them all. And finally, inter-team dependency, because you're mutually dependent. So it really defines, it can be really connected to any of these three aspects. Finally, we also have partnership. That is a pattern that was introduced by von Vernon, not by Eric Evans, but it doesn't matter. It's just another naming of mutualism, so we will not waste time talking about that. You usually don't, I mean, you don't draw that in your architecture board, that team have such a partnership. And finally, we have fully organizational pattern. Again, nothing to do with model propagation, which is customer supplier. And the customer supplier is a relation type in which the downstream team can have impact on the upstream team. And that kind of contrasts with what we said before, that the upstream team affects the downstream team. So how the downstream can affect the upstream. And this is about how we are handling requirements. To give you an example, I can be downstream team in video, or I can be the part of the video publishing team, and I want to use your functionality as access management team. I want to let you, for example, know that you need to enable access granting. For example, you are handling the API or publishing the API to enable access granting, and I need to use that API. So I'm dependent upon you, right? So I'm the downstream, you're the upstream. But if we define the customer-supplier relationship, if I am a customer, you're the supplier, and if I place a requirement, a business requirement to you, you're obliged to deliver that, as long as it's reliable. But you need to take my requirements, put them into your backlog, and make a promise to me when you will deliver that. So this is a relation where I can force you to do something. Okay, so this kind of organization pattern differs a lot from the open host service. When there's a consortium and there's a multi-purpose API where there must be a lot of teams joined together and they distill the API for the multi usage. Here, there might be a specific usage for my case. So when I made the decision that I'm a customer, you're a supplier, you need to fulfill my requirements. And this is very, very vital in terms of the inter-team dependency, because it sets up the communication path, because the consumer will be talking to supplier, not the other way around. Supplier doesn't care about who will come to them with their problems. And finally, we have one more last context map pattern, which is separate ways. And this is very similar to the free relationship when there's actually no relationship. It is the pattern connects to the situation when the two bounded context doesn't have a relation. Why can that happen? And in what situations? It might happen that, for example, we have a video publishing and we need to handle access. We need to grant access, revoke access. But it turns out that our business changes and we need to suspend the access, cancel suspensions. We want to introduce some invitations, etc. And the team that is handling the access management tells us, all right, we'll do that next year. What you will do? You're obliged to deliver your functionality in 1 month. So what you can do is to go separate way, to deliver your functionality your way, the way you like it, apart from what they are doing. So you're consciously choosing a different solution that is to be honest, they're part of responsibility, because that team used to be responsible for access handling. So there might be situations when you need to split paths in order to deliver. But the very vital thing is, the moment that you're splitting your paths, you need to plan for joining these paths. You need to give the responsibility back to that team. Let them rewrite it, let them, I don't know, you may hand over the application that you wrote to them, whatever it is, but you need to plan that. If you don't, you will inherit all the problems that are connected to the free relationship between teams when you have different implementations of the same things in different ways, and the cost of operations of development will be very, very high. All right, having covered all these context maps and types of relations between systems, we can write the context map. And this is the artifact that most of companies forgot about when designing their systems. So when I come to some company, they're talking that they're using strategic domain-driven design. Yeah, we do have subdomains, of course, bounded context, of course, sure. So show me your context map. Your context what? This is the most common answer. This is the missing part. You will see soon why. So this is the exemplary context map. Why exemplary? Because every decision in software is behind some. There's a trade-off behind every decision. What we should do, and what I usually do on trainings and in practice when I'm working with my customers, I work relation by relation and analyze what are the pros and cons of each setup. Well, let's place upstream, downstream here, and open host service here, and customer supply. What are the possibilities? What are the pros? What are the cons? And we make a conscious decision about each relation, each and every relation. That's hell of a lot of work. All right, so when we have that kind of map, let's have a look how it can help in our cases. So remember that we had a notification service that was listening to all those events and all those problems, that we have a bottleneck, we have inter-team dependency, two-way dependency, the cognitive overload, etc., etc. I won't be repeating that again. But now we have one more disadvantage of that solution, because it conflicts with the context map. Because what we see here is that if the user management, video publishing, popularity calculation, they all are downstream side of the relation with the notification sending, because they are dependent on them, because they want to send notification. It is their, it is their obligation that if for example, user is registered, the notification will be sent. They're the most interested parties in sending that notification. So they're downstream here, and because notification sending is generic, they should know nothing about any registration, payment. They shouldn't care. This is the only way to keep the service generic. So what can we do then? If we change the integration pattern from events that you have had here, that notifications, and it was listening to events, now the user management is sending command to the generic service. So we are changing, let's say, the orchestration in favor, we are changing the choreography in favor of orchestration. The discussion is much broader to choose between those, but here in this particular place, we are doing the switch from the choreography, from the event-driven architecture to sending commands. You can send commands asynchronously. You won't lose the decoupling that you strive for when choosing event-driven architecture. You can do that asynchronously. You can use Kafka, even though it wasn't designed for that purpose, but you can use that. I am doing that on my day-to-day job as well. So we can send this command, send notification. Everyone is sending the same command. We are just telling, hey, use this template. Here are the parameters. Just send it to this, I don't know, email address, phone number, whatever. What are we gaining with this solution? The notification sending, first of all, knows nothing about processes in which they are used. They have no idea and they don't care. So the cognitive load is minimized to the problem of handling notification and sending and integrating with all those SMS gates and whatever, right? The next thing, the context implementing the sending of notifications is fully generic, because as a result of not knowing anything about processes that are the clients here. Yeah, the communication is one way. Why one way? Because I'm just publishing the API in the notification service, and all the others are consumers. There's a very clear relationship between teams. They are dependent upon myself, and if they want to change, they just gather the consortium and we change it, right? And in this case, nothing is limiting our core subdomains. And finally, we don't need to prioritize anything. The notification team depends on no team with the accuracy to consortium. And as we said, there's no need for communication down to the point of the facilitation of the consortium. And we also have the compatibility with the context map because the patterns are aligned with what we have. Remember, if you have the upstream, the downstream shouldn't be emitting events, right? If you have upstream, you can listen to commands. All right, another example. We had video publishing communicating with the access management, and if we have a relation-wise, we have downstream on video publishing and upstream on access management. And here, if we have so, then the upstream shouldn't be listening to events of video publishing. How can we change that? You already seen that. There should be a command being sent from the video publishing to the access management. And we're solving all those issues that we used to have. There's a clear communication structure. This one-way communication, no cycles at all. Neither in software, neither in the organizational part of the job. No one is forcing changes to the core context, and we have compatibility with the context map. And let's have a look at the business process, because we also did have a conflict with the context map, and you already know in which places what should be changed. That there are some places where commands should be preferred over events. I mean, like see here, we are not resigning from event-driven architecture. It can be used. The choreography is fantastic pattern, but in certain cases, the more complex business process is, the more complex handling of the business process is, the more complex it is to test it, to maintain it, to get the idea of how it really works. So if we change from the choreography to orchestration here, that the video publishing is going to call commands to generic services like process payment, like send notification, like enable access granting, we solve the problem of the knowledge about the business process, because now it is located in the video publishing, not spread across all teams. Now you have the ability to unit test that. You no longer need the testing team making your delivery bottleneck. So, and also the business process is much simpler, much easier to observe, because there's one service that you can observe, right? And also the genericity is maintained. The payment service, the access management service, the notification setting, they know nothing about who is using them and why, right? Of course, there might be some contract tests, etc. So they might know the use cases, but in terms of generic services like payments and notification, access management is not generic, sorry, but notifications and payment are generic thanks to that. And finally, when like I said, it's not the only, there's no algorithm for choosing the upstream downstream relationship. There's no algorithm for choosing the best context map pattern. Is the art of compromise. So if you have a look at the diagram from the Eric Evans's book, on the y-axis you have control of all associated systems, and on the x-axis you have communications, commitment, the capability of teams. You see that on one end you have a single bounded context in the top right, when you have full control over actually everything. And there is, if you have more than one team, there is a huge communication overhead. They all need to synchronize, they all need to deploy together, etc. And on the other side, you have separate ways where you have little communication, actually no communication because it is separate way, and you have no control over the system. So you don't know how the implementation of integration with payments is going on everywhere. You have no idea. So the trick is about to choose between those two extremes. So you need to always find the trade-off. And to give you a bit more, actually we're kind of over time here, but I hope you you find that valuable what we have covered already. As just an just to give you an anchor what to look for further if you want to dig deep into the topic. I want to tell you that when I am designing software architecture, usually when I'm a part of the strategic refactoring, organizational refactoring of the architecture, I am following the pattern called reverse Conway manoeuvre, which is about designing the architecture first and then applying all those things to the particular team. I mean, first thing you do is not dividing your organization into teams and then figuring out who will do what. No, you're first designing the architecture, and then you'll try to figure out how teams should be structured, what competencies should you have in particular teams, and what responsibilities in teams you should have in order to, for example, limit their cognitive load, which is one of the most limiting factor of the effective team. So there's a very nice term coined by I really not sure if it was coined by Nick Tune or Eduardo da Silva. It doesn't matter, but it's called socio-technical architecture. Socio-technical architecture means that the system that we are designing is not the software system. It is a system of systems where there are actually two systems with the feedback loop. One system is indeed the software one, and the second system is the organization one. And all these teams should build and evolve software architecture, but the software architecture, by delivering value to the customers, should be the way of how we indicate our expectations to our team. So if there are any frictions on any of these connections of this cycle that you can see here, then your company simply won't be performant enough. And finally, there's a fantastic book from Mr. Manuel Pace and Matthew Skelton called Team Topologies, where these two gentlemen explain that there are 4 types of fundamental team topologies and 3 types of interactions that, combined in a certain configuration, can help you increase your delivery and operational performance. Any other combinations might not work good for you. And just walking briefly through that, the most important thing is to have streamlined team in your companies. Streamlined means that the team is aligned to the value stream. So a single development team should be responsible for the product end to end, starting from the analysis through development, testing, deployment, monitoring, observing. Everything should be handled by one team. You shouldn't have any handovers, like handover to testing team, handover to so-called DevOps team. That actually DevOps, if you have a DevOps team, you have little or nothing to do with actual DevOps culture. But anyways, you shouldn't have any handovers in the value stream. And in order to make the value streamlined teams effective, all the other teams needs to help them. And the most helpful team is the platform team. And usually when hearing platform, we think Kubernetes, virtual machines, etc. Yep, that is part of the platform. But also in terms of software architecture, every team that is handling generic contexts is a platform team, because multi-usage capability delivering team, and based on that capabilities, you can build numerous complex business processes. So every generic team, like notifications, like payments, like user handling, these are the platform teams. And developers' experience of streamlined team should be one of their goals on a daily basis. We also do have the enabling team that should be short-living team that helps in situations when there are lacks of resources. For example, when you need to start a project and the team will be free in the next month, so a couple of architects just sit and start writing and then do the handover. Or for example, a team that helps increasing the some technical skills of providing some technical workshops or something, so that the team can be self-efficient. And it might also happen that within your domain, subdomain, there will be some complex thing. For example, you are doing billing, but the billing algorithm is very complex. So you might make a decision to take the algorithm away and give it to another team to reduce your cognitive load. That's very rare case, but it is very well described by the authors here. And the interaction that you should optimize for is to have a particular contract, to have an upstream downstream relationship. It is kind of an upstream downstream relationship, kind of the same, which is called here X as a service. So you are using someone's API, someone's services, and you should optimize for that. And it can happen between Streamline team, or between Streamline team or platform team, and any other relations like collaboration where two teams actually are joined for some period of time together. It should be temporary. I mean, if you are joined with, for example, some platform team, your goal here should be to find the best boundary and to split. So, for example, when you do not have any automation in your company, you should join forces with your platform team, with your platform engineers, and work out the best pipelines, the best, I don't know, Kubernetes setup. And when you have the contract, meaning here are your pipelines, don't worry about the infrastructure. I get it. So you just work out the boundary, and then you have the boundary. You're moving towards the X as a service relation. And the final interaction mode is facilitation, which is what I already mentioned about enabling a team that tries to help some team in, I don't know, starting up the project or applying some patterns. And if they see that everything works, they're just moving away. So this relation should also be a temporary one. So we should be optimizing for X as a service, meaning upstream downstream relation. And yeah, I would like to end this talk with the very nice quote from Mr. Mel Conway, which is the following: "The design is almost never the best possible. The prevailing system concept may need to change. Therefore, flexibility of organization is important to effective design." I hope you liked it. I hope it wasn't too complex, and I hope you will get most value out of that. I don't know if we have time for questions, but even if we don't, I think I can even answer them somehow asynchronously via email, or I can contact.
We have one raised hand, so if you're okay with that, I can.
Sure.
Second, Alexander, hello.
Alexander.
Hello.
What is your question?
Can you hear me?
Yes.
Yeah.
Yeah, thank you for a great talk. Yeah, several questions. I wasn't able to ask questions in the chat. It was disabled. So
Oh, sorry. I will check. Thank you for saying that. I will check it. Maybe something is wrong.
Yeah, not sure. Maybe this is for myself only. Maybe for everyone.
So, you can check right now, and everyone seems like it's working now.
Yeah, thank you. So the question about mapping and patterns. So when we, for example, we are in a situation when we already have settled command, settled company and several teams working in several directions, maybe a couple of products. And when we apply these patterns like shared kernel or open host, is it like something which is already given and we need to recognize it, or it is still possible to do some changes, like to control and choose what we are going to have, like ACL or conformist or separate way?
Yeah.
What is your opinion on that?
Yeah. So first of all, sometimes the company is aware of the problems, is aware that the operational and delivery performance, that was actually the reason why I was talking about all those metrics at the very beginning, because you can measure, you can see, actually experience that the company is having problems. The time to market is very big. You have a lot of bugs, etc. So sometimes company is aware that there might be some changes. And usually the changes needs to be done on the low level, meaning architecturally, and on the high level as well. Your organization needs to change, and you're starting by planning the architecture and planning the strategic refactoring. But it doesn't change the fact that you already have some architecture and some patterns there already.
Yeah.
And identifying them might help you in spotting the problems. If you, for example, now don't feel the pain, that's great. But these patterns can help you identify places that should be optimized. So that's great. If you feel the pain, I mean, you should be planning the strategic migration to some new architecture, at least in some areas of your system. So I would answer your question to use context mapping patterns in both situations, both to analyze your state of art, your current state of your systems, and to plan for the future.
Yeah, thank you. Another question.
Sure.
Currently, I'm working in a company. We have something like 8 developers, so we have only one team and one product owner.
Yeah.
Can I apply this technique of context mapping to this situation? We have several products, but I would not say we have like a separate teams which communicate.
To answer your question, are you is your architecture distributed, or you have a monolith?
It's more monolithic, I would say.
Monolithic. All right. So, when we are applying the first part of strategic design, meaning subdomains and bounded context, the bounded context actually create modules. And it doesn't matter if you deploy module as a microservice or module as a module in your monolith, it will help you. Having a clear context map and map of your modules and relations between them will help you cleaning your architecture out so that you can scale in the future. I don't know your company, I don't know your use cases, but my experience shows that if you have a modular monolith where modularization is done according to these patterns, of course, we are not talking about customer supply when you have one team, right? But in terms of the patterns that are more technical, when you keep the genericity of particular modules, or when you are using events in places where you should events, you're using commands in places where you should be using commands, it helps you in the future in changing your deployment architecture. Meaning that, for example, you might decide to split the notification part and take it to another service and reuse it somewhere else, maybe assign some other team to do that. So you can apply all those patterns with the accuracy to this organizational one, because if you have one team that you want, it won't pay off. I mean, it won't give you much.
Yeah, thanks a lot for answers.
You're welcome. Okay, I see something in the chat now.
Yes. How can context mapping help moving from monolith to SOA architecture?
Yeah, I don't know if you meant service-oriented architecture or you meant rather microservices. But let's generalize this into the distributed architectures. Context mapping help you moving to from monolith in the way that. And if you want to read more about that, it is, like I mentioned, called the reverse Conway man-of-war. Remember that. So how you're doing that? You're planning your architecture, and in order to plan your architecture, there are several analytics techniques. I, for example, use event storming, whatever. When you distill your subdomains, design your bounded context, make the decisions about the relations, you have the 2B architecture. You know what you are heading to. It just helps you creating the roadmap for particular areas. So it doesn't solve the problem having the architectural diagram or the idea of how should things look like in the perfect world, but it gives you it's kind of a lighthouse where you should head towards, right? So what I'm doing on a daily basis is that when we create that context map, we try to identify teams that should be responsible for particular areas, and we decide to give this responsibility to the team. For example, first team will be handling, for example, payments, right? And these payments are now tangled in some nasty monolithic application in some big ball of mud, right? So they should be responsible for everything, for the state of art, for the current situation, and for the migration to 2B architecture. Because that team probably feels the pain of working with the monolith, wants to move to the distributed world as soon as possible. So they need to make a plan, a strategic plan, a roadmap for particular steps towards moving away from the monolithic application. And if you know where you're heading to, you can make that plan. And this is something that helps you in that. And what's more, you can see what are the stakeholders for your APIs, for example. If you're responsible for generic model, for some generic part of your system, you will know what are the customers, what will be the stakeholders who are going to talk to you for some APIs or something, right? So this is another dimension of this problem. So you'll have the bigger picture of what you will face in the future. I don't know if I answer your question. If not, just feel free to ask more.
Okay, maybe someone wants to raise hand and I'll try to unmute you. Or chat is open for questions as well. One more question. Can several teams be responsible for one piece of code?
No. The answer is very simple. No. One team, one piece of code, one team. Either way, in our case, you will have mutualism. You don't want that. You don't want to have the communication overhead in your company because it costs a lot. It costs a lot. And it usually ends up in, synchronization in terms of communication, in terms of testing, in terms of deployments, in terms of monitoring. You all probably work with monoliths. You know what I mean.
Okay, another question.
There's one more question. What books do you suggest? Yeah, of course, there's the Bible from Eric Evans. But to be completely honest, the Eric Evans book is very hard to read if you don't have experience in domain-driven design in general. It is a very good book, but maybe for the beginning, it won't answer most of your questions. But the author that I would recommend in this area is Mr. Michel Plout. He wrote a book called Hands-on Domain-Driven Design. You can buy it on LeanPub. I don't get any royalties for that recommendation, but it is a very good book taken from the practical, let's say, side of software design. And if you understand Polish, I also do have a talk on the Better Software Design podcast with Mariusz Gil when I'm talking about that case. So if you know Polish, you can also listen to that podcast.